Okay, hello everyone. Welcome. I hope you're all having a cozy, cold day. Hope you're staying warm. I hope maybe if you have a little dog like me, you're petting him. And I don't know, that makes me happy. But anyway, so what you should have right now is you should be watching this video and having the Unit 6 targets 1 through 3 note organizer filled out. So I am going to introduce the first couple skills of Unit 6 today in this video. Next week on Monday, we will talk about just a quick using transformations again with some graphs, so similar to what we did last semester. We'll have a review day on Tuesday, and then we'll do a quiz on block day. The first part of this unit, I think, is pretty chill, but you got to make sure you're watching the video, you're staying locked in, even though we have our cold day, because we don't have too much wiggle room this semester with scheduling. So because we reviewed before the Unit 5 test, we have to kind of put some of these skills together in this video for you today. Okay, so we're gonna, please make sure you have this out. Pause the video if you don't. We're gonna follow along, and then you're gonna complete the formative assignment that this video is embedded in. So if you're watching this video, you're probably also in the formative you need to, okay? That is something you're gonna complete, and I will be taking that as a homework grade, okay? So to start off, we're going to talk about operations of functions. So let's say you have two functions, like 2x plus 3 and x squared plus 1 on the left over there, and you want to add or subtract the functions. To add or subtract functions is really simple. You just combine like terms, something you already hopefully know how to do, right? So if I want to add f of x plus g of x, for example, well, f of x is 2x plus 3. I'm going to add x squared plus 1, which is my second function, and then I just combine like terms. So you combine like terms and you're done. So in this situation, my only like terms are 3 and 1 because those are both constants. 2x doesn't have any like terms. X squared doesn't have any like terms with it. So literally my answer is just x squared plus 2x plus 4. Please get in the habit of putting your terms in order from greatest exponent to least. That's called standard form. It's just good notation. And so that's all we have to do. It would be the same thing if it was subtraction, right? If it was subtraction, right, you would just subtract the terms and combine them instead of adding them, okay? One thing to watch out for with subtraction, again, if this sign was a subtraction sign, you would need to distribute the negative to both of these terms that come after it. That is a common mistake that is made with subtraction. You got to subtract both the terms after it. But other than that, if it's addition or subtraction, just combine like terms and you're done. That part's pretty straightforward, okay? Multiplying is also pretty straightforward, right? To multiply, you need to FOIL or distribute, right? So we are going to take 2x plus 3 and multiply it by x squared plus 1. We're going to do 2x times x squared, 2x times 1, 3 times x squared, and 3 times 1. And then boom, we'll have all our 4 terms. So 2x squared times x squared is 2x cubed. 2x times 1 is 2x. 3 times x squared is 3x squared. And 3 times 1 is 3. Now again, I would just prefer that you make sure that you're putting your final answer in order from greatest exponent to smallest exponent. And there we go, okay? And so that is multiplying. So again, so adding, subtracting, and multiplying, that's more review. You've FOILed terms together before. You've combined like terms. That's all that is. Something you may not have seen before is the final one, which is composition, okay? Now, composition is when you have two functions, is when you use one function as the input for the other function. So let's start with an example real quick that might prime your brain for what you're going to see. So let's say I have this function f of x. If I asked you to find f of 3, a lot of you know that you would just, oh, that just means I take 3 and I plug 3 in for x, so 2 times 3 plus 3. You would simplify and you would get your answer, right? So when there's a number in place of that x in the parentheses right here, that's the number that we plug in for the x into our function, right? That's something we've talked about last semester. But what if you have something that looks like this, f of g of x? Well, all that means is that you're going to take this g of x function. Let me erase my work here so you can see it. You're going to take this g of x function Notice how that is now the input that's in the parentheses. That's saying take the g of x and input it for x into the f of x function. So instead of inputting a number like 3 in for x, we're going to input the entire other function in for x. So again, we're taking, you see how g of x is in the place of x in the f of x function? That means it wants us to take g of x and substitute it in for x into our equation. So we're going to write f of x the exact same way, right? The only difference is that f of g of x, instead of writing 2 times x plus 3, we're going to write 2 times, and what is g of x? X squared plus 1 plus 3. So notice how the function up here and the function down here are the exact same, except instead of having x, we input the g of x function in for x as our input. So now instead of inputting numbers in for x, again, we are now inputting functions into other functions. So that's when one function becomes the input for the other, okay? So that is what we're doing here. And once you do that, you just simplify, right? You just simplify. So we distribute the 2, so 2x squared plus 2 plus 3. That simplifies to 2x squared plus 5, and we are done. Okay? So the first two, again, review pretty straightforward. The one, however, that might be newer is composition. It's when you don't input a number in for x, you input another function in for x. Okay? It can be a little weird, okay, but you just got to remember that instead of inputting a number like you would like f of 3 or f of 2, now if it was f of g of x, now your input is the g of x function, which in this case was x squared plus 1, okay? So that is all the skills, the algebra skills for this first part. Again, the only really new one may be composition, okay? All right, so let's take a pause there, look at this, write it down, okay? We'll do some composition on the next section of this video, but just take a second to pause if you need to. Okay, so now we are going to move on to the second lesson of the unit, or second skill, which is finding inverses, okay? So to find inverses, the thing that you have to be careful of is you have to be careful with your algebra skills, right? But that's the thing. If you know how to solve equations, you basically know how to find inverses of functions, okay? So what are we going to do here? Well, in order to find the inverse of a function, what we do is we follow these 4 steps, right? So the inverse of a function is a function that undoes the original function. If you want to find a function's inverse, you follow these steps. Change f of x to y. This is just so we have y's and x's. That's the only reason why we do this, because using f of x gets confusing, and so we change f of x to y. Then we switch y and x. Okay, so we're going to switch our y and our x. Just where each other are, we're going to switch their location. Then we are going to solve for y. And that's pretty much it. The only thing you have to do is to be proper about your inverse, you want to use the inverse symbol. So rewrite y as f inverse of x, right? That's the only difference, okay? So you want to change f of x to y, switch y and x, and then we're going to solve for y, and then we're going to rewrite y as f inverse of x to show that it's an inverse, okay? I'll get to the next couple blanks for the next second problem, but we're going to start by using these 4 steps in the problem right up here. Okay, so we're going to focus on this one on the top left. So let's start with the first step. The first step is just to change f of x to y. So instead of f of x equals 2x plus 4, now we have y equals 2x plus 4. Perfect. Second step, it says switch y and x. You don't have to keep putting 1, 2, 3, 4, but this is just how I'm showing you how they line up. So where there's an x, I'm going to put a y, and where there's a y, I'm going to put an x. I did not have to move this 2 with the x. Those are separate like numbers, like values. I literally just switched the location of the x's and y's. Okay, step 3. Now we are going to solve for y. So we want to get y by itself. So if we have x equals 2y plus 4, to get y by itself, we do two things. First, you always you undo addition or subtraction first when solving an equation. So if there's a plus 4 next to my y and I want to not have that so I can get y by itself, I would subtract 4 to both sides. So I'll have x minus 4 is equal to, these cancel out, 2y. And then continuing that work up here for number 3, if I have x minus 4 equals 2y, to get x by itself, what's the final step? I'm just going to divide by 2 on both sides because that will help me cancel out the value in front of y. So that means that y is equal to x minus 4 over 2, okay? And that's step 3 done. We have now solved for y. We wrote f of x as y in the first step, we switched x and y, and then we just solved to get y by itself, okay? Now, the fourth step is just writing the correct notation, which is, instead of y equals x minus 4 over 2, we should write f inverse of x equals x minus 4 over 2 to show that it's an inverse. And in fact, I'm going to write my final answer as x over 2 minus 2 because 4 divided by 2 can be simplified to 2. So I'm just going to simplify that part. But you could put it in either form. I'm not really going to be too picky about that. Okay. But again, I just followed those 4 steps and now we're done. Okay. Okay. So this will be something you'll have to practice, obviously, switching the x and y, solving for y, but it's really just solving an equation for a variable, right? As long as you keep track of where your variables are, that's simply what the problem is asking you to do, okay? And finally, the last thing you'd have to do with inverses is to show that two functions are inverses of each other. And there's a definition that says two functions f of x and g of x are inverses of each other if f of g of x, that composition we just talked about, if f of g of x equals x, and if g of f of x equals x. So if you plug the equations into each other for x, and you get a simplified result of x out for both, they are inverses of each other. And I'm going to show an example of this proof right now with the problem to the left, okay? So this is a problem I always start because it's something that comes up a lot, proving that two are inverses of each other. So let's start with the first one, which is f of g of x. So remember what we just talked about. This is saying that we're going to take this g of x function and we're going to plug it in for the x in the f of x function. So where that x is, we're going to replace that x right here with 2x minus 1. So f of g of x, instead of x plus 1 on top, it's going to be 2x minus 1 plus 1 over 2. Again, notice how this and this are the same, except I just replaced the x right here with 2x minus 1. Now I'm going to simplify. If I simplify the numerator here, notice how negative 1 and positive 1, those cancel each other out, right? So I'm just left with 2x over 2. And if these cancel each other out as well, I'm left with just x. So that first step, it worked out. We got what we wanted. F of g of x is equal to x. Boom. Perfect. That's what we wanted. We wanted to show that that composition is equal to x. Now we're going to go the other way. So we're going to do g of f of x. So I'm going to take f of x. That's my input now. I'm going to substitute it in for the x into the g of x function. So instead of 2 times x minus 1, I'm going to have 2 times, and I'm going to replace x with x plus 1 over 2. Again, it can look a little funky, but we're just taking this, for composition, we're just taking this function, right? And we are substituting it in for x into our g function, right? F of x is now our input, okay? So then we simplify. So what happens here is, well, we actually have, because we're multiplying and dividing by 2, those 2's right here cancel each other out because when you multiply and divide by the same number, those cancel. So we're just left with x plus 1 minus 1. And then the 1 minus 1, that's gone. So we're just left with x. Boom. That works. So we have officially proven that those two functions, f of x and g of x, are inverses of each other by doing f of g of x composition and g of f of x composition, okay? And that is all the things you need to know about inverses, okay? Now, I know it seems like a lot, okay, especially on a day where you're home and I'm not there, okay? But I promise that with practice and with taking the time to do the My Math Lab homework, okay, which is like 7 and 8, but also to make sure you're doing this quick assignment where I'm going to give you like one of each type of problem, and they're very similar to what you will see possibly on your quiz, right? If you work on these and you come to me with questions, right, things you need to know more about, right, it will be fine. You just need to practice, okay? One thing to note before you leave me today for your wonderful, cozy couch, bed, whatever it is, on My Math Lab, instead of writing, for example, composition as f of g of x, it might write it as f of g of x like this, and there might be this little dot in between them. Just know that that just means f of g of x, or it could go the opposite way, right? Like g of f of x on My Math Lab, right? G of f of x, when you're plugging in f of x into the g function, you could just, that could be written as g of f of x, g dot f. That's just showing the composition, right? So it's for some reason written differently on My Math Lab, but it's just it's the same symbol. So if you need to refer back to this for that, you know, for that clarification, please do, but it's still composition, okay? All right, wonderful. So thank you for spending time watching this video. I apologize if it's a little long. I had to squeeze in some stuff. I'm trying to really just make sure we're on pace. Please finish up the formative that this is attached to, right? It's going to be going in as a homework grade. If you have questions, let me know. And then also homework 7 and 8 are the homework so far assigned for My Math Lab. Do them to the best of your ability. If you can't get to all of it, come to me with questions. I'm more than happy to help. And I hope you all have a fantastic, fantastic weekend. Sincerely, Mr. Sieper.